A sphere with a radius of 4 inches with a cross-section is shown. Draw the cross-section if it occurs 3/8 of the distance from the sphere's center. Let us identify this center. Now remember that this was sliced horizontally by an horizontal plane, this. Now we're going to travel vertically down from the center, some distance down below, 3/8 of the radius. And then we're going to be landing on a new circle that has its own radius. Take a look. Remember now that horizontal plane and that vertical distance down will meet at 90 degrees. So we do have a right angle right there. Now if we go back to the center, anywhere and travel to the circumference, we're going to get that original 4, which is that radius. Now, what we do have is that distance down, we're going to try to find that. But we're going to label this new radius R. We are able now to set up a system to find that distance 3/8 of the radius. So let us work that out. 3/8 of 4. And if we should cancel 4 into itself, that's 1 time. And 4 into 8, that's 2. Then 3 divided by 2 will give us 1.5. So that distance that was traveled 3/8 of the distance from the center down is actually 1.5. Let's write that a little better. I don't think I like how that look. Okay, so let's put on that 1.5 right there. All right, a little better. Now we're going to be using the Pythagorean theorem to find R. Remember the longest side square, which is going to be 4 square, is equal to 1.5 square plus R square. 4 square is 16. 1.5 square, that's 2.25, plus R square. Let us subtract 2.25 from both sides so that we can isolate our R square. So let us do that. So we're subtracting 2.25 from both sides. So we're left with 13.75 on the left, and this is going to land us with R square. Remember, we need to find R, not R square. So it means then that I'm going to have to take the square root of R square, and then that's going to leave me with R, and then I have to take the square root of 13.75, and that's going to leave me with 3.708. So it's approximately 3.7. This is telling us that the radius of that new circle that we landed on after the slicing was 3.7 units. Now let us draw this cross section. All right, let us draw this cross section right now. So here it is. I have a grid. I'm going to identify any point as the center that I'm able to get that radius 3.7 swinging. So we're going to be using 3.7. So let us identify a point for our center right there. We're going to go 4 units to the right, and we want to go 4 units to the left, 4 units up, 4 units down, because we know it's less than 4. It's even less than 3.75. So we're going to go a little bit below 3.75. So I'm going to mark off some key points that will help me to swing my circle. So right there, I'm going to be swinging the circle. So let us just look at the cross section right there, going around. Definitely that's it. So the distance from the center to my circumference would be 3.7. And that is the cross section. Thank you for watching Daily Maths Concepts. And see you next time when we will be looking at another video. Bye-bye.